Hello viewers, so here we'll be looking at how to obtain the equations from graphs. Now, if you look at this graph, so what we need to do is we need to try to draw the helper graph. And if you look at this, you will see that I can have like a complete semicircle here, and here I can have a half. So this is a semicircle, and so the purple one now you can see is the graph of what is our helper. So this is our helper graph. So let's focus on this first to identify what type of graph is this. If you look at this graph, it begins from here. So at pi over 2, it begins from the maximum point. So this is likely a cosine graph. So it means the helper is going to be of this form. The helper is going to be of the form A cosine kx plus b plus c, right? And why is it a cosine graph? Because at pi over 2, which is the starting point, the value for the purple one will be at 1. So it means it's at maximum. So now, since if we see it as a graph of what? As a graph of cosine, then we can find what is the amplitude, and we can find also the period, right? So we're going to follow the same procedures to find amplitude is clear. The amplitude is just going to be the distance from the baseline here. So you can see the maximum point is what is 1. So let's see, how do you find the amplitude? You see, this is the maximum point, which is 1, and the minimum here is what? Is minus 1. So this is your capital M, and this is your what? Small m. So the amplitude, if you remember, we use half into m minus small m, and this is going to be half capital minus 1 minus 1, and this is just going to be 1, because this will be 2 divided by 1. And then the period, which is 2 pi over k, is nothing but end minus what? Beginning. So this is, what is the end here? The end, you can see, is 5 pi over 2 minus beginning is pi over 2. And you can see this is only 4 interval, right? This is 1 interval. And from here to here is 2. From here to here is 3. And from here to here is what? Is 4, right? Now, so this period is equals to this. And now this is what's, this minus this will give us 2 pi, right? So you see that clearly this is just 2 pi. That is the period. It's 2 pi. Then the horizontal shift, x is equals to minus b over k. The starting point is pi over 2, so it means pi over 2 is equals to minus b over k. And what is k? We already found k, right? Did you find k here? Okay, I think here, let's see, something is missing here. We can find k from here. Because remember, here is 2 pi over k, right? So it means that 2 pi over k is equals to what? 2 pi. And this simply means that k is 1. So here, when we come here, horizontal shift, we are going to divide b by what? By 1. So it means that b is equals to minus pi over 2. Then we can use the maximum value to find c. The maximum value is what's absolute value of a plus c, which is equals to capital M. And absolute value of a is 1 plus c is equals to capital M, which is also 1. And this means that C is what? Is 0. So it means that the graph, the helper graph, Y is what? Is cosine. K is 1. So this is just X plus B. B is minus pi, right? Okay, so let's see something here. What is B? B is pi over what? Let's see, minus B over K. And this is pi over 2. So B is minus pi over 2. Okay. All right. So what do we find? We find the B's, and then we can just substitute. All right, so here we're just substituting K. Remember K is 1 and our B is minus, right? So substitute B to be minus. So here we're going to have so here will be minus pi over 2, right? And C is 0. So this is it. So it means our original graph, the purple one, it's going to be Y is equals to what? Now it has to be sec, right? So we have X minus pi over 2. Okay, so this is our equation. Okay. So let's just create more space so that we can write this also in terms of what? We can also write this in terms of sec. I mean in terms of cosec. All right, so what I say is that the graph is just going to be A is 1, so you have cosine X minus pi over 2. Now this is 1. So the purple one, or let's say this original, we are interested in the blue, so the blue one is going to be Y is equals to sec X minus what's pi over 2. So this is our original graph that we are interested in. And now you can also convert this to what? You can convert this to as many as you like. You can convert it to using the what? The co-function identity. Co-function identity helps us to convert from sec to cosec. So this is the same thing as cosec. Now this will be what? This will be pi over 2 minus x minus pi over 2. Because I know that sec theta is the same thing as what? Cosec 90 minus theta. So this is going to be cosec of what? This is pi over 2 minus minus. So this will just become pi minus x. And then you can take a minus if you like. You can write this as cosec. We can write this as cosec by taking a minus out. So this can be cosec minus, so that you have x minus pi. And then you take this minus out since cosec is odd. So this is minus cosec. And then you just have x minus pi. So these two are the same. All right, so let's move to the second graph. For the second graph is we're going to follow the same. You try to first of all get the graph of the helper. And how can we get the graph of the helper? We just sketch it. This you can see. We can complete this one by having this here. Something like this. So this is the helper. Okay, so if you look at the helper here, this helper is like a sine graph because you are starting from the origin at where? At the starting point. So this graph is nothing but in this form. It's going to be a sine. We have sine kx plus what? Plus b plus c. And you can see that here, the capital M here, what is the capital M? This is going to be like half, and this is going to be like what's minus half. So it means the absolute value is going to be half m minus small m, which is going to be half into m is half minus m is minus half, right? So everything is just going to be just 1 over 2. Because this is half plus half, which is 1 divided by 2. So it means that our A, we have absolute value of A is equals to half. And you can see clearly A is going to be 1 over 2 because there is no reflection, right, for the graph sign. And then you can see that the period, which is going to be 2 pi over what's 2 pi over k, is going to be the same thing as the end minus the beginning. And this is 2 pi by k is equals to, the end is what? 6 pi minus what's 2 pi, right? And so 2 pi over k is equals to 4 pi. And what does that mean? That tells us that k is going to be what? It's going to be 1 over 2. Yes, k is 1 over 2. Now, we can look at the horizontal shift. Our horizontal shift x is minus b over k. So, which is going to be 2 pi is equals to minus b over, what is the k? The k is half. All right. And this means that what, if you multiply this, so b is going to be like minus pi, right? Correct? Yes, because you can multiply half times this. This is just going to be pi. So b is minus pi. Now, absolute value of a, I can use the maximum point. What is the maximum point? Absolute value of a plus c is equals to what's m. So we're using the maximum value now. So this is absolute value of a is already half plus c equals to what's m, which is also the same thing as half. So it means that c is equals to 0. So it means the helper graph is going to be what? So this is the helper. Is going to be y is half sine k, which is also half x, plus b is what's, so this will be minus pi Yes, I think that is it. Plus C, which is equals to 0. Okay. And now what can you do? We can always check if our helper is correct. We can test point. So for example, now let's find f of what? Let's find f of what? 2 pi. And if everything is correct, f of 2 pi is supposed to be 0. So f of 2 pi is half sine, half times 2 pi minus pi. And this will be half sine. This will just be pi minus pi, which is 0. So 0 divided sine 0 is 0. So this is going to be 0. So it means likely, most likely it's correct. Yeah. Now, so for the blue graph now, which is what we are interested in, it's just going to be, we just change what now? It means that y is going to be half, this is sine, so it's going to be cosec, right? Cosec half x minus pi. And then you can try to write it as sec, which is going to be sec pi over 2 minus all of it, which is x over 2 minus pi. And then this is going to be sec of what? Pi over 2 minus pi is going to be minus pi over 2, then minus x over 2. You can leave it like this, or you can factor out minus, but we know that sec is what? Sec is even, yes? So even if you factor out minus, it won't make any difference. So let's see, this is cosec. This is cosec. Here it becomes sec because we already factor out minus. So what is okay? Yes. So I think that is that here. Just like I said, here you can use the fact that we have sec. You can take a minus out so that it still become x over 2 plus pi over 2. And then you can consume the minus because sec is what is an even function. All right. Now, here is going to be the same. You just need to identify, first of all, the helper. So let's try to identify the helper in this case. This is going to be something like this for the helper, right? And then what can we see here? If this is going this way, so we have this, and we need to figure out. All right, so for this question, this is the C questions. Here, what we need to do is we still need to find what is the helper graph. So we'll try to do something here. Now, if you try to sketch this like this is complete, right? Okay, so we'll have this. But you can see that once we are at the minimum, then we have to go either like this and this, right? So this side is okay, but this side does not make sense because if this is the helper, then it means that the red graph is supposed to start from either here. So this is not correct. But if we look carefully, we can do something. This is a graph that is already shifted. So let's shift it to the point 1. And then we take it from here like this. Yeah, you see this makes sense. Because this, once you are here, you have to go down and then you will back to the baseline, right? And here also you back to the baseline rest. So you see the red one is now going to be what we're interested in. So, or we can just remove this side. So this will just be this. We can remove this as well. So if you see the black one is the helper graph. Is the helper graph. And you can see it's nothing but cosine graph. It is the graph of a cosine. Is it cosine or sine? I think it's sine. Is it sine? Yes. Because if you look here, let's see, at this point is good. Now we need to know that the baseline is no longer what? Our baseline is the line y is equals to 1, right? So it means at the starting point, we are starting from the minimum. So this is going to be a graph of cosine. So this is going to be a graph of a cosine kx plus what? Plus c. Not just starting from, yeah, since we are starting from minimum, it means there is a reflection, yes? So we can see we're using the black one now. So this is going to be our capital M is 2. Our small m is what? It's going to be 0. So small m is 0. Yes, which is the minimum. So if you want to get A, absolute value of A is going to be half m plus m minus m. And this is nothing but 1 over 2. Capital M is the 2 minus small m is what? Is 0. So this is just going to be 1. So it means absolute value of A is 1. But here you can see that A is going to be minus 1 because we are starting from the minimum. Because at the initial stage, which is the initial point, which is minus pi over 2, what is our value? Our value is 0, which is the minimum point. So, and we know that is the graph of cosine. So if you start from the minimum, it means there is a reflection. So that is why we took A to be minus 1. Now for the period, which is what the period, we know the period is 2 pi by what? 2 pi by k. It's nothing but what? End minus the beginning. Okay, so this is 2 pi by k. It's equals to, what is the end? Is 3 pi over 2 minus the beginning, which is minus pi over 2. So we have 2 pi by k is nothing but what? 2 pi. So k is simply 1. K is 1. Then the horizontal shifts, x is equals to minus b over k. And here you can see our initial point is what? Minus pi over 2 is minus b over k, which is 1. And this means that's what? B is pi over 2. Now, we can find the maximum value, which is given by absolute value of A plus C is equals to M. So the maximum value for the helper graph, as you can see, is 2. So this is 1 plus C is equals to 2. And this means that C is equals to 1, right? So it means if we come to write our equation, if we come to write our equation, we will write we will write y is equals to what? A Remember, it is a cosine of what? Kx plus b plus c, right? So this is all right. So let's still keep it in black. So y is what? A cosine kx plus b plus c, right? So this is a is minus 1. So cosine k is 1 plus b is pi over 2, then plus c, which is 1. So this is our equation, right? This is our equation. Then now we can convert this to what? To what we want. So what we want is y equals to minus sec now. So it's going to be sec x plus pi over 2 plus what? Plus 1. So that is the red graph. And that is what we want. And which we can also write as what's cosec, if you want. Pi over 2 minus x plus pi over 2, then plus 1. And this is just going to be minus cosec. And this is going to be minus, this will cancel this. So this is just minus x plus 1. And we know that cosec is what? Is odd. So this minus can come out. And this will just become cosec x plus 1. So it's either this or this one. They are the same. All right, so thank you for watching. This is how to obtain the equations of cosec and secant from GeoGraph. Thank you for watching, and do not forget to share with your friends and also subscribe to this channel. Thank you for watching.